Hello everyone, today in this video we will be discussing all that you need to know from the DSA module 1 for your externals so that you can easily score more than 80% marks. We have 9 questions here taken from the previous year papers and the model paper. Don't miss any of them, watch the video till the end and please do like and subscribe, it helps me make more videos like this. So without wasting more time, let's get started. The first question is define data structures. Okay, and with a neat diagram explain the classification of data structure. What is the first question? First question is define data structures. Second is explain the classification of data structures. And the third question is what are the operations that can be performed on data structures. So three questions are there. Together it is 12 marks. Okay, so 4 marks for each of them. So definition is not 4 marks. So let's look what the definition is. Okay, definition is data structure is a particular method of storing and organizing data. Okay, what we do here, we will be storing the data and organizing the data in a computer so that it can be used efficiently. Okay, that is called as data structure. Now the classification is of two types. There are two classifications in data structure. First is primitive and second is non-primitive. Primitive means the basic data types like int, char, bool, float, etc. These are the primitive data types, which are the building blocks. Okay, the least ones, smallest ones. Okay, and in non-primitive type we have the multiplication of these. Okay, means more int is called as array and char is called as linked list. So when we join all of these in multiples, we will be getting different types of data structures. Okay, so non-primitive have two types, linear and non-linear. Okay, linear means we'll be having an indexes and it will be sequential order. Non-linear will not be having a sequential order, it will be arranged in a different way. So linears have static and dynamic. In static we have arrays, and in dynamic means the size can change. Okay, static means size is fixed and dynamic means size can change. Okay, so here we have linked list, stack and queue. Three types are there. Okay, and in non-linear we have trees and graph. This is the classification you need to make. After that there are two types of data structures, first primitive and second is non-primitive. You have to write something about it as well. So the data structure which can be manipulated by the computer is called primitive types, integer, char, boolean. Non-primitive types are which cannot be manipulated. Okay, which cannot be manipulated by the computer is called non-primitive type, array, linked list, etc. And in non-primitive there are two more types, which is linear data type. It shows the relationship between adjacency elements. Means in linear data type this is the first element, second element, third element, so this is connected with this. Okay, before this is coming, after this is coming, that is linear. In non-linear there is no relationship. Okay, it will be in random ways connected. Okay, like this, like this, like this. Example is trees and graph. Okay, the third question was operation on data structure. So these are the following operations, easily you can write. Create means create a new data structure. Insert means inserting a new record to the existing structure. Deleting the records, searching the records in the given structure. And sort means making it in a particular order, like increasing or decreasing order. Merge means joining two. Okay, that is called as merge. Traversal means again going through all the elements. Okay, accessing all the elements one by one. Moving on to the second super important question for 8 marks, which is explain briefly the functions of dynamic memory allocation. Okay, there are 4 functions of dynamic memory allocation. So the 4 functions are malloc, calloc, realloc, and free. Okay, malloc, calloc, realloc, and free is used to delete. Okay, means again free up the memory after the usage. Okay, so heap is the unused memory allocated during runtime. Okay, heap is the place where we do the dynamic memory allocation. Okay, now the first type is malloc, memory allocation. Okay, in malloc it allocates the memory during runtime. When the runtime programming is executing, it is allocating the memory. Okay, that is called as memory allocation malloc. Here we'll be writing the type, which is void here, and star malloc you have to write, and what size you want to capture. If you write here as 5, then 5 blocks in the memory will be captured for the particular function. Okay, second is contiguous memory allocation. This function is used to allocate continuous blocks of memory. In the previous one there can be different places where the blocks is allocated. Okay, it might not be contiguous, here it will be continuous. Okay, so here the size is given, the size will be specifying how much size it should be, and 2 means the block size is 2. Okay, sorry, this is the count. Okay, this is the count, not size. This is the count. 10 blocks should be allocated of each size 2. Okay, so 2 2 2 2 like that, 10 blocks are allocated. That is called as calloc. Realloc means suppose previously we allocated a memory 10, now we want it to become 20. That time we will be using realloc. Okay, so what we do here, the function reallocates the memory size with the new size. Okay, so void realloc, void star ptr, which one you want to reallocate. I want to reallocate the ptr which is allocated here, and what should be the new size, that I'll specify here. Okay, and after the usage we'll be freeing it by using the free function. So int I star pf I is equal to 2, P is equal to ampersand I. So P will be having the value 2 and F is equal to P. So F will also having the value which is pointed by P. So when we do free P and free F, at that time what will happen, the P and F both will become free. There will be nothing remaining. That is called as free. Okay, we'll be using free like this. And after that, if we try to make some changes to that, it will be called as dangling pointer, because making changes to something which is not being pointed to, it is pointing to nothing. Okay, and we are trying to make change to nothing plus 2, that will throw us error. Okay, it is called as dangling pointer. Okay, moving on to the third super important question, differentiate between structure and union. Okay, what is structure, what is union, you have to differentiate. Second, with suitable example, discuss the self-referential structure. The structure which refers itself is called a self-referential structure. Also, they are asked about nested structure. So let's understand what is a structure. Structure are basically a user-defined data type that stores similar or different data. Okay, it is a data type. You can imagine it as a box where different or the same data can be stored. Okay, so this is the example here. Struct student, and here we will be having s name of type character and age of type int and average marks of type float. Now student will be a box wherein the s name will be stored and age will be stored and average marks will be stored. Okay, that is called as structure. Now what is union? Union is a user defined data that is with same or different type of data but shares the memory location. This is the keyword you need to write here. It shares the memory location. Okay, what do you mean by share? Okay, see, for example, if I define a union num and write int a and float b, and I declare another I mean the instance of it. So n1 is the union here. Okay, n1 is what? Union, which has a and b. Okay, but now we have a union n1 which can be used to store either a or b, either int or float, both can be stored. Okay, so suppose that n1 is there and we execute n1 dot a is equal to 5. So what happens? 5 will come and sit in n1's place. Now if we again do n1 dot b is equal to 6.52, in the same place b's value will be substituted and it will become 6.52. A's value will be overwritten. So a and b both are sharing the same memory location. Whichever latest value comes, that value will be sitting here. In structure, what will happen? A will be having a different value place and b will be having a different place, separate places. Okay, so that's the main difference between the structure and union. The keyword you need to write is shares. Okay, the union shares the memory location whereas structure does not. Now what is a self-referential structure? Self-referential structure in C is a structure that includes a member that is a pointer to the same type of structure. Okay, so we declare a structure. In this case we declared a structure node. Now this if we use this same node to create another structure inside it, it will be pointing to the same structure. That is called a self-referential structure. Okay, this is the example you need to write. Next is nested structure. They are asked. Nested structure is a structure which has another structure inside it. Okay, it might look like similar to this, but there is a difference. Okay, here this is a declaration part. You need to understand this is a declaration part. Okay, in declaration part we are pointing the same node to the same structure itself. Okay, but here what we are doing is, let's take this an example. Okay, struct date. We have created a structure called as date, which has int day, which has month, and which has year. Okay, three things are present here inside struct date. Now what we do is we create struct employee. Inside that we create a character name array and we also create a date dob. Now what is date? Date is already a structure which is defined. We are using a structure inside another structure, not the same structure. Okay, so in that case it will be called as nested structure. If it is under the same one, it is called as self-referential structure. Okay, now to manipulate the struct data, we'll be declaring employee emp.dob.date is equal to 9. So what happens inside employee, it will go to dob. Inside dob it will go to the date. Okay, we have made the change to the date, right? So sorry, this is day. Okay, not date. And emp.dob.month is equal to 2. So inside emp it will go to the dob. Inside dob it will go to the month and it will save that date. Okay, like this by using the dot operators we will be accessing inner levels. This is the implementation of data structure, I mean the structures. Okay, moving on to the fourth super important question, which is what do you mean by pattern matching? Okay, first question they have asked, what do you mean by pattern matching? Second, outline the Knut Morris Pratt KMP algorithm. This is the second question. Third is illustrate it to find the occurrences of the following. They have given a problem also to solve. It is an 8-mark question, very important question. It has appeared in almost all the papers. So let's have a look what is pattern matching. So basically, pattern matching, by the name itself, you can understand we are finding a pattern. Okay, it refers to finding a string in another string. So in this string, we are trying to find out the particular string here. Okay, that is called as pattern matching. Now, KMP algorithm will come later after I explain you with the example. Okay, Now let's take an example and understand this. Okay. Now see, in KMP algorithm, or what you have to do is, firstly you need to write the string here which is present. Okay, this like this you have to write the string. Okay, this is the string which is given to us. Next is you need to write the pattern here. Okay, this pattern ABCD ABD. This is the pattern given. You have to write it like this, and after that write prefix above it and write the indexes values. From 1 you need to start here, and 0 will be written before that. Okay, and here you just need to write this much, and you put I on top of this string, and on top of 0 you put J. Now your next step is what? Next step is compare I with j plus 1. Okay, I repeat, compare I with j plus 1. Now what is I is pointing to a. Compare this value with j plus 1. What is j plus 1? J is 0, so 0 plus 1 is 1. So compare with 1. With 1 we have a here. Now here I have a, and here also I have a, so these both are same. Whenever these both are same, increment both of these. Okay, you have to increment both of these. Okay, whenever it is same you have to increment both of these. Now you will also think that how I wrote these values are written based on the following. See, a initially a has appeared before this, no it has not appeared, so 0. B has appeared before this, no B has not appeared, so 0. C has appeared before this, no it has not, so it is 0. D has appeared before this, no it has not, so it is 0. Next, a has appeared before this, yes, and in the starting point you need to see, in the starting point a has come, right? So that index you will be writing here. The a points to 1, so you will be writing 1 here. And next, B comes directly after A, the same thing which is here also. So it should be continuous. Okay, A has come, after that B has come. So in here also A has come, after that B has come. What is the index value of B? 2. Write 2 here. Next, D. D has come previously. Yes, D has come previously, but it is not the starting point. It should be starting point, or else it should be continuous. If it had been A, B, D, at that time the D value would be written 3 here. But that's not the case because C is in between and D has come after that. We cannot take D as a separate thing. We have to write 0. Okay, this is called as prefix table. After you've written the prefix table, we'll be continuing. Okay, now compare I with j plus 1. What is the value of I is b. J plus 1, j is equal to 1, 1 plus 1 is equal to 2. What is 2 pointing to? It is pointing to b. B is equal to b. Increment both I and j. Okay, so here we'll be writing j, and here we'll be writing I here. Okay, now again the I is pointing to C, and j plus 1. J plus 1 is also pointing to C. So both are equal. Again increment. Okay. After that I will be incrementing here. Now next, I is pointing to A and j plus 1 is pointing to D. Is both equal? No, both are not equal. In case when both are not equal, what you have to do is, you will not make any change to I once I move forward, it will not move backward. Once if there is a change like j plus 1 is not equal to I, at that case what we will be doing is, we will be seeing where j is pointing. J is pointing to this column. In this column we have last value as 0. Wherever the j's last value is present, that place we will be shifting j. Okay, so j will be again shifted back to 0 because of this 0 which is present here. Okay, after that again we will continue with the search. Okay, again we will be doing the same thing. I is equal to I is equal to a, and j plus 1 is equal to a. Both are same, so we will be incrementing j and incrementing I also. Okay, after incrementing I and j, what is j plus 1? J plus 1 is b, and I is also b. So again we will increment both of them. After we increment both of them, we will be checking the next one. Okay, next one is c here. J plus 1 is also c, so we increment both of them again. Okay, so this will also be incremented. Now j plus 1 is d and I is also d. In that case again increment. Okay, after we have incremented this, we'll be incrementing it here. Now sorry, this is j, right? Now j plus 1 is a and I is also a, so it is fine, it is correct one. I will be incrementing both of them. Okay, we'll be taking j here. Next, I also will be incremented, I will be taken here. Now what is j plus 1? J plus 1 is b. What is I is also b, so again increment. Okay, again we'll be incrementing. Now what is j plus 1? J plus 1 is d. What is what is I is a. So here I have got d, but here it is I. That is a mismatch. Whenever there is a mismatch, will not move I once it has moved forward, it will not look backward. We'll be shifting the value of j, and j's last column value is 2, so we'll be shifting j to 2. Okay, we'll be shifting j to second value. Okay, now in this case, I and j plus 1. I and j plus 1, is it same? No, it's not same. So where we have to go with j? J will be going to the last value of the column, which is 0. So j will be going here. Now again, j plus 1 with I you have to compare. Okay, j plus 1 is a, and I also has a. When it is same, increment both of them. Okay, so we'll be incrementing both of them here. After that, what is I value? I value is b. J plus 1 is also b. So we'll be incrementing the j value again. Okay, and I value also will be incrementing again. Now again, j plus 1 is c and I is equal to c. When both are same, increment. When both are same, what you will do? You'll be incrementing both of them. Okay. Now, what is I? I is D. What is J plus 1? J plus 1 is also D. Whenever it comes same, you have to increment it. Okay, well, once we'll be incrementing it, again we'll be checking. J plus 1 is A and I's value is A. Okay, if it is same, we'll be incrementing it. Okay, so we have incremented it. Again, J plus 1 is equal to B, I is equal to B. Both are same, increment both of them. So we'll be incrementing I to here, and J plus 1 is D, but I is equal to C. In case this is a case of mismatch, right? So it's not equal. J plus 1 is not equal to I. In that case, what we will do, J will be going to the last column present here, which is 2. Okay, so it will going to the 2 here. Again, we'll compare. J plus 1 is C and I value is also C. So we'll be incrementing both of them. We'll be incrementing I also from here. Now again, I is pointing to D and J plus 1 is also pointing to D. So we'll be incrementing both of them. We'll be taking J here and we'll be taking I here. Now, J plus 1 is A and I is also pointing to A. It is same, so we'll be incrementing both of them. J is here and I is here. Now, what is J plus 1? J plus 1 is B and I's value is also B. And both are same, we'll be incrementing both of them. So we'll be incrementing this also. Okay. Now, what is J plus 1? J plus 1 is D. When J plus 1 is D, and what is the value of I? I is also D. When both are same, you'll be incrementing both of them. So J will come here, and I will be coming here. Okay. Now observe one thing carefully. J plus 1, it's reached the end. Okay, J plus 1, we have nothing else to compare here. When J reaches the end, okay, I'll be writing here. When J reaches the end, okay, when J reaches the end, pattern has been matched. Okay, pattern is found. Okay, pattern is found, because unless and until pattern is found, we cannot reach the end, because every time we'll be comparing the next one. So if it has reached this point, means till this point it was matched, so we'll be taking I minus 1, that point till the starting one. Okay, so A B C D A B D A B C D A B D, this is the point where the match has happened. Okay, so the pattern is found in the string. Okay, this is the KMP algorithm you have to write. Okay, so the same thing you have to do here also, but while using KMP algorithm, how you'll write in answer sheet is every step you do. Okay, whatever you will be doing, every step that you'll be noting down. Okay, for example, I'll be writing for one step. Okay, so first iteration, what you'll be writing is iteration 1. Okay, in exam sheet you have to write it like this. Okay, iteration 1, and after that you'll be writing first here. First what we did, J is equal to 0 and I is equal to 0. Okay, J plus 1 is equal to, what is J plus 1? A. Okay, and I is equal to, what is I is pointing to A only. Okay, then you will be writing a match, m plus plus J plus plus. Okay, like that you will be writing. Whenever you are going back also, you'll be writing that particular J's value, I's value, which is getting specified here. Okay, suppose there was a mismatch and J had to go to 0, so you'll be writing in the exam sheet, J is equal to 0, it has gone to 0 because of mismatch. Okay, like that you'll be writing. So in this way you'll be writing for all the iterations, then only you can expect full marks. Okay, so now you have got to know, right, what is the KMP algorithm. Now what we'll be doing is we'll be seeing how do you remember this one. Okay, so P match means pattern match. Okay, you'll be writing int pattern match char string and pattern. Okay, two things are given to us. First is char string and second is char pattern. Now pattern and string length will be calculating. Okay, I will be taken care for the string and J will be taken care for the pattern. Okay, and len s means length of string, strlen string, len p means string length of pat. Okay, by using this we'll be able to get the length of string and pattern. Next we'll be forming a while loop. Okay, I is concerned with the length of s and J is concerned with the length of p, until the whole string of I gets over, and until the pattern gets over. Either of these, if it gets over, we'll be stopping it, but until this gets over, we'll be continuing. Okay, now what will we do comparing I and J plus 1, that only we have discussed, right? I will be compared with J plus 1. If both are same, increment both of them. If it is not same and J value is 0, that means I plus plus. If J has come to the first position in the prefix, we'll do I plus plus, right? Okay, that one. And if it is not in the final position, the J will be looking for in the last column what the value is there, right? J will be always looking at the last column what value is there, like this. Okay, and it will go to that position, so J will be going to 2 in this case. So either of these things, first if it is equal, then it is fine, keep on incrementing both I and J. If J is 0, means you have to increment I, there is no other choice, J cannot go back further. and if it is not both of those case, prefix of j wherever it points you have to go there. Okay, next, if j is equal to length p, what does j is equal to length p means? If j's value and length of p is 8 here, so j's value and the value which is present here 7, so according to different indexes, if we do it in computer, it will be starting from 1 2 3 like that, so the length will be same here. Okay, so in that case, if j is equal to length of p, that means you have reached the actual pattern and the pattern is found. So what we'll be doing, I minus len p will be returned. Okay, see, this is a ternary operator. Here, if this condition is true, this will be returned. If this is false, this will be returned. This being false means pattern is not found, because the pattern never finished means it never reached the end and the string has ended. So we'll be returning -1. In case if it is found, we'll be returning I minus len p. I minus len p means I minus len p, the length of the pattern before that, means in the whole string which index location we are starting the which index location the pattern has been matched, that it means. Okay, so that will be returning in case the pattern is found. Okay, so this was about the KMP algorithm. Don't miss this, it's very important from the exam point of view. Moving on to the next super important question, we have write functions in C without using built-in functions for comparing two strings, concatenation of two strings, reversing a string. Okay, three things they have asked here. We have to write the functions. Okay, what we have to write? We have to write the functions without using the built-in functions. Okay, so this is the 8 mark question. So how we will be approaching this? First is compare two strings. What do you mean by compare? Compare means checking. Okay, we'll be checking two strings. Okay, so here let's have a look what is present. So in the first one, comparing two strings, the function we have defined which returns 0 if the strings are equal. Okay, this is the conditions which is being defined for this particular problem. Okay, so first you have to write 0 if strings are equal, negative value if first string is lexicographically smaller, positive value if the first string is lexicographically greater. Okay, if 0 comes means it is equal, if 0 does not come it means one of the string is not equal. Okay, so this is the code you have to write here. First, int compare strings and take the two strings const char star str1 and const char str2, two strings we have taken which we need to compare. After that there will be a while loop. Okay, while loop until str1 and str2, means until str1 exists and str2 exists, means both strings are not over, you have to run this loop. Okay, and each time we will be checking if str1 is not equal to str2. If both are not equal, that means we will be returning str1 minus str2. If both are equal means we'll be continuing, we'll be ignoring it and we'll be doing plus plus, str1 plus plus, str2 plus plus. So in both of the strings, the first letter we are checking. If it is not same means we will be returning, if it is same means we'll be incrementing and checking the next two, then we'll be checking the next two, then we'll be checking the next two, like that we'll keep on doing until one of the string gets over. In that case the while loop will be over and we'll be returning this one. And if it does not over, at that case both the string values will be equal and the value which will be returned here is 0. In case both strings are same, that means this value and this value will be same, right? So same minus same is 0, so we'll be returning 0, which will mean that strings are equal. In case one of the strings is shorter, this will end faster, and that faster value, that shorter value will be present here and the longer value will be present here. When this subtraction is done, it will be not equal to 0. So that in that case we'll be able to identify if the two strings are same or not. Okay, moving on, next one they have asked is concatenation of two strings. Concatenation means what? If I write abc here and I write doll here, okay, so concatenating these two strings, what will happen is abc doll. Okay, this is known as concatenation, adding up and joining two strings. Okay, here also you'll be writing void concatenate strings and you will be using two strings, char str1 and const char str2. Now you have to add the const str2 to str1. Okay, means first str1 will be there and when it gets over str2 will be there, the content values. Okay, so how do we do that? We'll be running a while loop here, while str1 plus plus move to the end of the first string. Okay, so the strings will be stored like this in a form of an array. So we are moving to the end of the first string. Okay, in str1 we will be moving to the end. After you have moved to the end, take str2 here and copy the characters from the second string. Okay, in str1 you will be copying str2. Okay, means see, we have reached the end of the string. Okay, when we copy it will be getting added to the next one. Okay, and then we do str1 plus plus, str2 plus plus. When you do that, the next alphabet will be copied and again plus plus, the next alphabet will be copied again plus plus, and the next alphabet will be copied, like that all the values which are present in the str2, one by one it will be copied one after the other. So what happened, str1 is present here and str2 came beside this one, so that is called as concatenation of the strings. Okay, and to terminate the concatenate concatenated string. All the strings end with this symbol. Okay, this is the null symbol. So after the concatenation has been done, two strings are present here. We will be adding this symbol here to denote that the string is ending. Okay, that is called that is the function. This is the function you need to write for concatenation of two strings. Moving on, we have the third question which they had asked, which is reverse a string. Okay, reversing a string means if I write here apple. Okay, if I reverse the string, it will become elppa, right? Elpa. So that is called as reversing a string. Okay, how do we do that? So in reversing a string, we'll be writing here void reverse string, okay, the function name, and we'll be accepting a str, which is the string which needs to be reversed. We'll be taking the length as 0, and we'll be taking start and end. Okay, start is equal to str, means the starting of the string will be pointed here, start, and ending of the string will be pointed here as end. Now what you have to do, you have to take the end value and put it in the start, the second end value in the second place, the third last value in the third place, fourth last value in the fourth place. Like that, if we keep on doing and exchanging the first value with the last value, second value with the second last value, like that, what will happen, the string will get reversed. Okay, like let me show an example. So suppose that I have written abc. Okay, abc, I'll take c and put here, and I'll put here, then b already it's in middle, so I'll not do anything. Okay, if it case in it's the four letters a b c d e, I will put here, d I will put here, and ab I'll forward it here, so it will become e d c b a, like that it will become. Okay, so this is the shifting which we need to do. First, find the length of the string. So we are calculating the length of the string, str length, and length plus plus. Always it will become plus plus until it reaches the end of the string. Okay, so in length we will have how much length it is. Okay, next, after that, end is equal to str plus length minus 1. Okay, point to the last character, the string plus length minus 1. Okay, whatever the string is, the starting point plus length will reach to the last point, and we are taking minus 1 so that it does not reach the null character, because last is the null character. Okay, before null character we need the answer. Okay, so in the whole string we are coming to the last position before the null character. Now this position is to be put in the first place, right? So that's why we have written this algorithm here. Start is less than end, while start is less than end, this start and this is end, while this is lesser. Okay, that means that we still have things to push here. If all the things are pushed here, means this will become in the last value. Okay, so that's where the string will end. Okay, so we are taking the temp value here is equal to start, and inside start we are putting end, and inside end what will come, temp. So basically we are swapping start with end. Okay, we are swapping it. After that we will do start plus plus, end minus minus. Start plus plus will take the second character from here, end minus minus will take the second last character from here, and they will be switched. Again, start plus plus and end minus minus, these two will be switched. Again, end minus minus, start plus plus, this will be switched. Okay, so like that each character is getting switched, and from the first and last, second and second last, third and third last position, so that eventually we'll have a reverse string. Okay, moving on to the sixth super important question, which is write a function to evaluate postfix expression. Okay, so how do we evaluate the postfix expression? Also, it's given, illustrate the same for the given postfix expression. Okay, the one expression is given to us, we have to apply the same method and find out the answer for this one. Okay, so we'll be discussing this also. First, write a function to evaluate a postfix expression. This is for the 8-mark question. Okay, so function to evaluate postfix expression. First you will write evaluate postfix. Okay, what you will write, evaluate postfix, and the expression will be accepted here. Expression is like this, something will accept here which is to be evaluated. Okay, and we'll have a stack here and initialization stack, means a stack will be created and initialized with 0 and null value. Okay, after that we'll run a for loop. Inside the for loop, it will be starting from I is equal to 0. Okay, the for loop will be starting from 0 and until it reaches the end, expression of I is not equal to null, I plus plus. So in an array of expression we'll be taking each character one by one. Okay, so this is the first character, second character, third character, fourth character. Whichever character we take, that will be stored in ch. So ch is the every character. Okay, so ch will be a first, then ch will become b, then ch will become c, then ch will become minus, and so on, like that it will become. Okay, so we have ch. What we are checking, we are checking if the character is a digit, push into the stack. Okay, so there are some rules. If it is a digit, okay, if is digit ch, push stack ch minus 0. Okay, we are converting it into an integer and then we are pushing it into the stack. Okay, means inserting it into the stack. Next, if the character is an operator, pop two elements from the stack, apply the operator and push the result back onto the stack. Okay, so suppose that stack has the value 1 2 3 and plus has come, this is the operator, so it will become true. Else means in the part where it is not digit, else part will become true. Here what you have to do is, it is 1 2 3 plus, right? So whenever plus comes, we will be taking the last two digits adding it up, it will become 5. So the answer will be 1 and 5 here. So it was 1 2 3, so it become 1 5 here. Okay, so we are taking those two values, the last value and the second last value. Two times if we pop, first last value will be out, then second last value will be out in the stack, right? So val2 and val1 will have those values. If the character which is there, it is not a digit, means it is should be an operator, there is no other choice. If it is an operator, if it is plus, inside stack what we have to push, value 1 plus value 2, because plus is present here. The 2 3 we had separated, right? So 2 3 will be done plus here. Whatever the answer is there, that answer will be pushed back to the stack. So the stack value will be 1 and 5. Second, if it is minus, do minus and push. If it is multiply, do multiply and push. If it is divide, do divide and push. Except that if it is 0, don't divide it. And if it is none of this, then default means invalid operator. If you put something like a modulus operator, that is not supported here, right? So in that case, there will be a message called as invalid operator. Okay, that was about the function to evaluate a postfix. Now we'll understand the actual problem. Okay, so in this problem, the steps you need to follow. Okay, what you have to follow, some steps are there. Okay, so this is the expression which they have given, and after the expression they also given that assume a is equal to 6, b is equal to 3, c is equal to 2, d is equal to 5, is equal to 1, and f is equal to 7. The values of each letter they have given us. Your first step is to substitute those values. A will become 6, b will become 3, c will become 2, minus minus, d will become 5, e will become 1, f will become 7. Okay, after you have written this one, you have to create a table. Inside the table you have token and stack. Okay, only two things are needed, token and stack. Now in token, what you will be writing is the every character which is present here, one by one we will be writing. Okay, so first we will write 6, then next is 3, so I'll be writing here 3, next is 2, I'll be writing here 2, minus is here, I'll be writing minus, and so on till the end we will be writing. Okay, after that you have to write stack here. Okay, inside stack you will be pushing both numbers and operators. Okay, so if any number or token comes, copy paste it here. Again 3 came, so after 6 we'll be writing 3, then 2 came, we'll be writing 2 here, then an operator came. Whenever an operator came, we have to do that operator between the second last and the last number. So 3 and subtraction is here, so and 2 is here, so 3 minus 2, what answer is there, put here. Next again continue, 5 came, so we'll be writing 5 here. Next multiply is there, multiply between 1 and 5, 1 and 5 is 5 only, so we'll be writing here just 5. Okay, after that plus came, plus between 6 and 5, so 6 plus 5 is 11, so we'll be writing 11 here. Then 1 came, we'll be writing 1 after that one. And dollar came, dollar means power, power means 11 power 1 is equal to 11 only, right? So we'll be writing 11 only. Next is 7. Okay, okay, next is 7, so 11 plus 7 will be happened, and that will become 18. Okay, so this is how you will be solving evaluation of postfix problem. Okay, evaluation of postfix problem. If any question comes, evaluate the postfix, you have to do it in the same way. Okay, moving on to the next super important question for 6 marks, we have convert the following from infix to postfix. Okay, two types can come. First is evaluation of postfix. Second is infix to postfix conversion. Okay, so here, for example, C, A star B star C plus C, B star E plus F is given here. Okay, so if the conversion is given, again you have to make the table only. Okay, but there is a priority order also. The priority order you have to remember. Okay, so first is star, this is the highest priority, multiplication. Next comes division, that is the next priority. Third priority is the modulus operator, finding out the remainder. The next one is plus, and the last one is minus. Now in this, keeping this in mind, we have to do the following. Okay, now see, conversion of infix to postfix. Okay, first the equation which they have given, you will be writing it like this. Okay, the equation which they have given, you will be writing it like this. Next you will be making a table, the same table you will make infix and postfix. Okay, we have to convert from infix to postfix. In between we will be using stack also, so stack will be present here. Now observe carefully, whatever the tokens are present here, everything is a token. A is a token, star is a token, and opening bracket is a token, B is a token, and star is a token, C is a token, and everything all the way till the F is a token. So all these tokens one by one will be writing in this column. Okay, after that you'll be writing stack as hash. First, every time stack will be having a hash value. Hash means empty, nothing is there. Okay, and whenever a letter or a number comes, okay, whenever a letter or a number comes, okay, you have to observe carefully. Whenever a letter or a number comes, you'll be putting it into the postfix. Okay, don't miss this, putting it directly into the postfix. If a operator comes, okay, if an operator comes, at that time we'll be pushing to the stack. Okay, if an operator comes, then only we'll push to the stack. Okay, so now star, is star an operator or a letter? Star is an operator, so we'll be pushing it into the stack here, and A will remain as such. Then opening braces, opening braces is also a operator. Now whenever an operator comes, we'll be pushing it like this. Okay, we'll be keeping on doing, and it depends on the priority also. See, the star and this one, opening braces, that is in the same priority. Okay, here actually the opening braces and closing braces also there somewhere in between. So these are all same priority, and these two are different priority. Okay, plus and minus is different priority. Okay, so after that B came, I'll be writing A B. See, after A we'll be directly writing B here. Then again star came. After star came, it's the same priority, the same level priority between this and this, so we'll be keeping it as such. AB will also be as such. Next came C. When C comes, ABC will be writing, and when plus came again, now observe carefully. Plus has come here, and the top of the stack is the sub means multiplication. Multiplication is a different group, and the plus is a different group. So when different group comes, this is the lesser group, this is the higher group, right? Because they're decreasing priority. This is the higher group and this is the lower group. Okay, observe carefully. This is the higher group which has the multiplication division, and this one, and lower group has plus and minus. Whenever a lower group comes and already higher group is there, I'll repeat, whenever a lower group comes, okay, whenever a lower group comes here and already a higher group is present here, that time the replacement will happen. Okay, what do you mean by replacement? Plus will come and it will go and sit it in this place, so it will become as plus here, and this value it will be coming out here, and this place will be writing it. This will only happen when lower is coming and already higher is present. Okay, the reverse scenario also we'll discuss, but for now let's move on. The D is here, so we'll be writing here D after that, and again star came. This is the reverse scenario. See, star came and this is the lower priority. When higher priority comes and already lower priority is present here, you have to just add it beside it. Okay, means star came here, no replacement will happen, you will be adding it beside it like this. Okay, so this is the answer till now. Okay, and here we'll be having ABC star D. Now E came, put E here. Now again the closing braces came. Whenever closing braces came means, closing braces came means it came like this, means this cancels this, and whatever is in between you have to take it in this order. First this will come here. Okay, and second plus will come here. Okay, I'll repeat again. Till E we had ABC star DE. Now what happened is closing braces came. Whenever closing braces came and there is an opening braces, you have to take the symbols out in this order. First star will come out, next plus will come out, like that. Okay, and after this is over, this all will get cancelled. Okay, means these two are already out, and the closing braces will cancel the opening braces. Next we have star only. Okay, we have star only, then plus came. So whenever plus comes, it will replace the star, so the star will be replaced here by replaced means this will go here. Okay, this will go here, and plus will be written in the star's place here. Okay, that is called as replacement. After that F is present here, F will be directly transferred here, and after that, since nothing is present and whatever is present here, that will be popped. Okay, so plus is present here, that will be popped at the end here. Okay, this is the way you will be solving infix to postfix. Okay, there is another question, second question they are given, we'll be solving it together. Okay, now observe carefully, I'll be doing it in front of you, what all steps you need to follow here. Okay, so let's get started. First this symbol came here, so I'll be writing here this symbol. Postfix will be empty only. Okay, if any letter comes, then only I'll put here. A came, I'll be putting here, but I have to keep this also, this content as same only. Then plus came. Whenever plus comes and the opening braces is this one, what you have to do is you have to put a plus beside this one. Okay, so you will be putting a plus beside this one. Okay, so plus is present here. Next A will be copy pasted from there. Okay, again our opening braces is present here. After that, when another time opening braces is present here, what we'll be doing is we'll be pushing it like this. Okay, like this. Okay, so here we'll be putting it like this. Hash is here, opening braces, plus is here, and another opening braces present here. Then A will be as such. Okay, and B again, for the B also there is no other symbol is added, so this will be remaining like previously only. And after A I'll be writing B here. Next star came. Okay, when star came, I'll be have to write the star in this way. Okay, so we'll be writing the star in that way. Okay, so we'll be writing that in the next line. Okay, hash plus this and star, and AB will be remaining as such. Next C came after that. When C comes after that, this will be remaining as such, and C I will be writing it in the after AB. Okay, ABC it became. Now there is a closing braces. Whenever there is a closing braces, whatever is present here till the next opening brace, that I have to push it out. Okay, so what will happen, the content remaining here will be this one, and this star will come out, and it will become ABC star. Okay, now this is the top of the stack. Then divide came. Divide has come after this one. Okay, so The priority, if you remember, it was star, divide, modulus, plus and minus. So this is a decreasing priority. Okay, decreasing priority. Now this is higher priority. The which has come, it is higher priority, and which was already there, it is lower priority. In that case, we'll just add up to the beside it. Okay, I'll add up the division beside it. If this was lower and this was higher, that time replacement will happen. If lower comes, whenever higher is already present, we'll be replacing. But if higher comes and lower is present, we'll be just adding it up to the next. We'll be just putting it here, and ABC again opening braces is present here. So the another opening braces will be adding it beside this one. So it is plus here, and here it will become as opening braces. Now ABC star will be as such. Okay. Next D came. D came, we'll have to just copy paste it from the top here, nothing changing the symbols part, and D will be recorded here. Okay, D will be written here. Then minus came. Minus came, and this is opening braces. So after the opening braces, we'll have to write it as minus. Okay, after opening braces, we'll be writing here as minus. It will be A, B, C, star, and D. Okay, now E came. When E comes, what you have to do? When E comes, you have to push it to the existing stack value. No change in the symbols. You'll be just pushing it here. A, B, C, star, D, E. Okay. Now a closing brace came. Okay. So the closing brace came. Whenever closing brace came, whatever is there present here, that we have to transfer it. Okay. So here the content which will be remaining is, it will be plus and it will be divide, and this all will get cancelled. So cancelled and minus will come out. Okay. So when minus comes out, it will be AB star DE minus. Okay. After that, again a closing brace come. Whenever a closing brace come again, nothing will be remaining here, because until this closing phase, everything else will be pushed out and it will be cancelled. This closing phase will be cancelled by this one opening phase. Okay. So only hash will remain, and plus and divide. First divide will pop out and then plus will pop out. So here the final answer will be A, B, C star D minus. First divide will be out and then plus will be out. Okay. So this is your final answer from infix to postfix. Okay. Moving on to the eighth super important question from this module, we have what is a sparse matrix. Okay, what is a sparse matrix? Give the triplet form and also find the transpose. Three things they have asked. First is what is sparse matrix. So a matrix where majority of its entries are zero. Okay, majority entries in which it is zero, it is called as sparse matrix. Now, what is a sparse matrix is done. Next they have asked is give the triplet form. Okay, what is a triplet form? This is the 2D array which we have to consider. Okay, in triplet form, first you'll be writing here row, column, and value. What you will be writing? First you'll be writing row, column, and value, and you'll be writing a of 0. A of 0 means this is the a array, and a zeroth row. In the zeroth row, what will happen is you'll be writing 5, 4, 8. Now what is 5, what is 4, what is 8? 5 is the number of rows present. Okay, this is the number of rows, 1, 2, 3, 4, 5. In the array, 5 rows are present, 4 columns are present, 1, 2, 3, 4. So 4 will be writing here. And how many values are non-zero? Okay, that is the count of non-zero values. Inside the array, how many values are non-zero? First is this 1, 2, 3, 4, 5, 6, 7, 8. Right. So 8 values are non-zero. We'll be writing it here. Next, after that, from the first row of the triplet, what we will be writing is in which row and column the value is present as non-zero. Okay. In which row and column? In 0 and 0 it is present, and the value is 10. So we'll be writing here in 0, 0 the value non-zero is present, it is 10. Next where it is non-zero, the next where it is non-zero is this one. This will be 0th column and 0th row and 3rd column, and the value is 40. So 0th row and 3rd column, answer is 40. Okay, like that we will be fetching all of them sequentially one by one, and we'll be noting them down in the triplet of the matrix. Okay, that was about the triplet. Next is transpose of a matrix. This is very simple. Here all you have to do is firstly the row which is present here, that will be writing it as column, first column. Second row you will be writing it as second column, and third row, fourth row, fifth row you'll be writing here it as third and fourth and fifth columns. Okay, that's all you have to do. This is called as the transpose of a matrix. Very simple question. Don't miss this at any cost. Okay. Moving to the last super important question of this module, we have define a stack. Okay, firstly they have asked what is define, what is a stack, define the stack, and we have to write a program in C to implement push, pop, and display. Three things are there in stack: push, pop, and display for the stack using arrays. Okay, so basically you have to write first the definition of stack. Stack is an ordered list. Okay, what is stack? It is an ordered list in which insertion and deletion can happen. Okay, those are made at one end called as top. So in the stack there is an end called as top here, and the additions and deletions will be happening from here, and it is an ordered list. Okay. Next, the implementation of stack. The code for push. For push, you have to write this function. Void you'll be writing, then you'll be writing push. The item which needs to be added or pushed, will be specified here. If top is equal to max minus 1 means the stack is there and top is here, means already everything is full here and overflow cannot happen, so the adding will not happen and will be returning. Else what will happen, if there is space, we'll do stack of plus plus top. Okay, so wherever top is there, we'll first put the top in a blank space here, and then in that blank space what will be stored is item. Okay, that is the code for pushing. For popping, it's very simple. We'll be writing pop and which item we are popping, and item del, we'll be saving that item here. If top is equal to minus 1, return 0. Top is minus 1 means nothing is present in the stack, so we'll be returning 0. Okay, means since there is nothing present in the stack, we cannot delete or pop anything. Next is if there is something present, we'll be taking that value inside int dev item del and top minus minus. So what will happen is first value which is there in top, that will be get coming and storing in int item del, and stack of top minus minus means the top value will become minus minus. So it firstly it was pointing here, now it will be pointing to this last value. Okay, that is the item del. Inside item del it will be stored and will be returning the item del. Okay, so in the case of pop, this is which item is pop, that will be returning. Okay, next is code for display. In display what will happen, first we'll take int I. Okay, very simple, we'll be traversing here. So first we'll be taking int I here, and if top is minus 1 means stack is empty, else we have to print the elements. How do we print the elements? I is equal to top, I is greater than equal to 0, I minus minus. I is equal to top means it will start from here, and it is greater than equal to 0 means it will come and come till here. Till it comes here, it should run, and inside this what should happen? Inside this we have to uh, print the stack of I. Okay, that's all. You have to print the stack of I. The stack of I, wherever it is pointing, you have to print it. Again next we have to print it. Again next we have to print it. So it keeps on decreasing until it becomes greater than or equal to 0. Okay, once it becomes less than 0, the code will be stopped and all the elements will be printed. Okay, that's for the display. Now to combine all of this, you can use a menu function here. In the same way, here we have some declaration of variables. While one, printf, we have to print, enter the choice, push, pop, display, or exit. Now whatever the choice comes, it will be stored in ch, and we'll be taking that ch and comparing it with different cases: case 1, case 2, case 3, and case 4. Case 1 means push, right? Push means you have to insert the element. We will be checking which element is to be inserted. We'll be taking that element here, and we'll be calling the push function. This push function is the thing which we have defined here above only. This is the push function. Okay, here it will come and it will store the value. Like that we'll be keep on doing. If we want to item deletion, if we want to reallocate it, or it will be executed, we have to exit it. Okay, so display will be called whenever we call as a display here, and whatever we have defined in that, that will be displayed. Okay, so this is the code for implementation of stack using arrays. Okay, that's all for this video, and please do like and subscribe. Don't miss any of these questions, and thank you so much for watching. I'll see you in the next one.